Just
Okay,
to
wait a
let
minute.
you know. Yeah,
Can they hear me too? Of course they can hear me. Good.
yeah, of course.
Oh,
Yeah. So you can also tell Dave that we're live. So yeah.
yeah, we're live. So don't see us anyways.
Well, he can talk, but you know, there's some of the things that he cannot actually say right now.
Uh, I can't see live. T'es sur YouTube?
Yeah, but this could take a little while.
Ok. Parce qu'habituellement, je devais apparaître.
So I'm gonna name it EDU2027E live streaming course.
Live. Live.
Course 2. So what we're going to talk about today, yeah, digital technology through 21st century. All right.
Okay, so you're live on my TV and it's delayed. So,
Yeah, it is. 15 seconds, around 15
yeah.
seconds.
Oh, so I have time to correct you. Oh my God, I hear myself now.
All right. So everything's set up now. We're going to wait for a little while for student to connect to
Yep.
our live streaming.
And can you tell when people are on? Does it pop up?
Well, actually, I know there's one person, which is, well, one person, one machine is connected, which is your TV, actually.
Yep.
So yeah, I can see that.
Cool.
But I cannot see um, who are connected, no. So
Unless they do comments.
yeah, unless they do comment,
Yeah.
which is actually a 15 seconds delay uh, when when I speak and when they hear me. So I like to remind this a lot.
Yeah, that it's live, but it's not like super precise.
No, it's not. Well, it can be super precise, but this way I will be losing some video quality.
Oh yeah.
So so they cannot read the everything that's written on those slides. I will be showing.
Right.
Hang on.
You hear the noises in my background? Like, is it loud enough that you hear it in your
All right.
speakers?
Sorry.
But no, I'm asking if you can hear me, like my noises from my mic.
No, your background noises. No, I can't hear
Okay,
anything.
good.
Yeah. Well, anything. I can hear Dave, but not anything else.
Okay. Because he's just doing a few things, but after that
All
he'll be
right.
done.
All right. No, it's okay. We didn't
Be
hear him a
gone,
lot.
evil one.
Forever. No, not forever. Um. So yeah, I think everything's set up for
Yeah.
stream. So welcome everyone that's joining us today. As I told you yesterday, Alex is going to be with us all. Well, I mean most of the time. Um, well, mostly for helping me out with the English part of the class, And also, she will be feeding the discussion as you know, chatting may be a little bit more difficult where when we're not in person. So yeah, Alex, I'll let you maybe introduce yourself. Um, you know, I don't know. Maybe tell us what your training is and what you do, uh, what you teach, and which grade do you teach? Maybe.
All right, so my name is Alexandra. I currently teach high school first cycle in Saint-Roch de la Chican. My training is English second language. So I have a bachelor's in teaching from the UQTR, Université du Québec à Trois-Rivières. And as well as my high school teaching, I have experience in primary with adults and with inmates. So I've actually had quite a lot of clientele in the moment,
Mm-hmm.
but yep, teaching teenagers right now.
All right. So the way that you guys can, differentiate the Alex and I's the level of English language. So yeah, the Alex is better at speaking with me than me. So yeah, this is the way that we can differentiate one from each other. Alex, I asked students yesterday what were their, I call it relationship with the technology, but I want you maybe to tell us a little bit about your experience through experiencing digital technology. Well, I
Yes.
mean, during your whole life, like when you were at school yourself, pu- uh, pupil, pupil. I don't know how to say it.
Yeah, when I was learning, basically.
Yeah, yeah.
Okay. So, well, I am a bit older than you, so technology wasn't that good back
Two
then,
years
first of
older,
all.
actually. 2 years.
Um, so in class, what we had literally was the white, well, not the whiteboard, the blackboard,
Uh huh.
the chalkboard, and if we were lucky, we had a retro projector uh, in high school as well. So primary high school, that was the big technology. Once in a while, we had like Canon projectors, not even linked with a board or anything. We had to pull down the screen, and if we had a school that had the budget, we could watch films or things
Uh
like
huh.
that. So that was pretty cool. Then, when I started university, all the interactive whiteboards started coming out. So that's the first time that I was put in touch with those. So we learned how to use them. We learned how to integrate them and have an interactive classroom, which was great. So now, of course, I use it in my classroom. I have for all my levels when it's available, of course, depending on the area that I teach, on the clientele. And other than that, if we're fortunate enough to have schools that provide iPads or laptops to the students, there's a lot of other interactive, well, games or questionnaires that we can
Mhm.
do, which I personally really like.
Yeah.
It keeps the students fully engaged, just having something in their hands most of the time.
Mhm.
And you can really use it for active learning, which is cool.
Cool.
Also, there's a bunch of little things that we can use in the classroom. I have one that I always forget what it's called, but let's say that it's like a magnifying glass, so a lens
Yeah.
that I can use to look at a text or a book that is paper form on my desk. And while I'm doing that with this device, the students can see it on the board. So
Okay.
if you're reading the text out loud with the students, they can follow at the same time.
Oh,
So
that's cool.
if they're more visual and they like it like on a big picture,
Mhm.
that is also a solution. And if you're correcting something or if you want to show someone's copy, for example, you
Yeah.
could do that. So for me, that's that. Of course, music, not the audio tapes that we used to
Yeah.
have back in the day in English in my case, but it's very convenient to have
Okay.
a computer that is linked to a board that makes sound. We take that for granted, but great invention.
Yeah, because actually we don't. Well, in my I'll speak for myself, but I didn't really know until what yesterday maybe where where this where this come from, where all these where all of these technologies come from, and um, most importantly, how does they work? Because I'm pretty sure that if I ask you how the if you know how a computer actually works, um, maybe could not be able to you won't be able to answer me. Isn't it true?
Well, actually, um, I happen to have a boyfriend that builds
Oh, okay.
PCs.
Okay, so he knows he, he
So
knows all this stuff.
he knows how to do it, but I don't know. So I couldn't do it myself, but I do listen and know. I have a certain knowledge to a
Okay.
degree, but if you ask me to have a look at your computer and fix it, for example, I could never do that.
Okay, so and basically how a computer can send information and be able to at some point create documents and pictures and out of you know zeros and ones. So this is the most basics, yeah, of how computers are working. So yeah, and when we take a step back and take a look at how many technologies that are you know that we are interacting that we interact sorry with um, every day, we might realize that most of our lives are that we don't understand how it works. So I'm talking about, yeah, of course, computers, but also smartphones, internet, Wi-Fi, Bluetooth, tablets, and what I'm missing out. TVs, like my dryer actually is connected to the internet. I didn't even know that was possible because
So
I
you
did.
can start your dryer with an
Yeah,
application, for
yeah,
example?
yeah, and it
Okay.
yeah, and it tells me it sends me notifications that to let me know that the cycle has ended. So is it useful? Well, not really, actually, because well, in that
Well,
situation,
I think that it can be useful because if you're anything like me, I'm doing laundry and then I'll forget that I'm doing laundry, so it can stay there for a long time. And then at the end of the day, I realize that I have stuff in the washer that needs to
yeah,
be put to the dryer.
yeah.
So for that situation, yes, I guess it could
Mm-hmm.
be useful, but yeah,
Do
does it
we
use up a
really
lot of
need it?
data? Does
Yeah,
it use up a lot of energy? That's things to
yeah, and
consider as
how?
well.
Yeah, how does this work actually? Because we don't even know how internet works and what actually is internet and uh, no, but that's that's true. If I
It's like a greater force.
yeah, yeah, it's kind of somewhere a parallel universe or something like that that we used to interact with, and the comparison with the parallel universe is kind of relevant. Well, you will see. I found a cool website during my researches for this class, and yeah, I'm kind of excited to show you guys what I just found. So yeah, today we're going to address the topic of how did we manage to get there, to be every day connected to the internet, every day connected with each others, and how does that and what makes that possible? Electricity, you said? Yeah, of course, electricity, but more than that, you know. So, what led to the world that we live in today? What was the implication and, you know, the role of digital technology in our society since, let's say, 1949, which I identified as the, year of entering the digital era, digital age. You'll see what I mean later on. But it's kind of fascinating to see how quickly and how fast it evolves without even knowing that technology was changing our society and yeah, it's a little bit scary, but you know, we we don't like it. It's not like we have the choice to, you know, keep keep moving with the flow. So yeah. So I have a few quotes that that I want to start it with. Is it clear at the screen? Can you? Yeah, we're able to read. All right. So technology is too complicated. I don't understand a thing. Nothing is working, and I'm about to throw my PC through the window. So this is a person first time using technology that says that. I don't know if that's your case, Alex, but even with I don't know how to say it, but technophile like me. Uh,
Technically, yeah.
yeah, so even me, which I love technology, sometimes it happens to me that I want to. Um, we have a cool French word for that is défenestrer, which basically means uh, pass something or someone through a window. So yeah, first time we used technology and teaching was way better than we were not when we were not sorry surrounded by digital stuff. Is that something that you've been hearing oftenly
Um,
at
I
work?
have heard that often, of course, because I work with teachers that are much older and wiser than me, but unfortunately, the technology side of things, even though our school board provides us with certain trainings, they're not mandatory. So some teachers will refuse to go that extra mile to try to be in the loop with what's new,
Mm-hmm.
I guess.
Yeah.
Um, but even for me, I mean, not so much with the school tools, but in life, I think that technology is a great thing, but also it makes us lazy. If I
Yeah.
could do a good example, I've been playing The Sims all my life, okay? And now I tried Sims 4, but it's completely different, and I didn't enjoy it
Mm,
because even though it's more detailed and
yeah.
overall better quality, it's completely different and it's very difficult. So for me, it wasn't convenient. So
Mm-hmm.
why would I be using this
Yeah.
greater, newer, better technology when I know how the old one works? So I do understand this, but this is exactly what we're trying to change, right? So
Yeah, but technology actually, you said that it makes us lazy, and you're not wrong about it. Actually, technology, especially when it comes to the use of technology in a pedagogical context, um, well, it meant to make our life easier, our teaching easier. And what I say to students and teachers is that if technology doesn't help you or doesn't make your teaching life better, why using it?
yeah.
Because we're not like you said mandatory to use those technology, and I think teachers and people in general feels that they're obligated to use those technology because but
Well,
yeah.
I think that nowadays as well, well, being in 2020, there's the social pressure of our students are growing more and
Mm-hmm.
more in this technology. These kids are actually born in this era of
Yeah.
great technology. So there is a certain pressure of me, well, if I speak for myself,
Uh-huh.
saying if I really want to grab their attention,
I
if I
have
want
to.
it to be,
Yeah.
yes, interactive, they're born basically with phones attached to their
Yeah.
hands. So if I like, it's more how can I compete with that?
Uh-huh.
Not that you necessarily need to have all the fancy tools. Not every school has access to that budget wise, but it is fun to still have access to some of those and to an extent.
Yeah, and right, you kind of spoiled one of those one of those elements that I point out when it comes to the importance of yeah, the importance of implementation of the technology in classroom. But that's okay. That's okay. We'll get to it in more details later on. Let's move on now. Um, that's great. That's great. Um, so I started with this title, ICT, Digital Technology Through History. So I've come to some sort of reflection about it, and I think we've come to a point in humanity where we can not only read And There They Were None by Agatha Christie,
Mhm.
but feel what yeah, Hercule Poirot experienced in that mansion on Devon Coast. So nowadays with all the technology, we cannot only you know read and imagine stuff, in but we also can live those stuff by the using of like virtual reality or amplified reality and other technologies that makes us um, that makes the
It
experience a little bit
immerses
more
us. Yes.
immersive. Yeah,
Mhm.
exactly. And I don't know if you remember the first time you went to IMAX.
I'm going to burst your bubble, but I've never been to an
You've
IMAX
never
theater.
been to an IMAX cinema, really?
But the
Theater?
first
No, really?
time I used virtual reality,
Yeah,
um,
it was
it was actually
at my
with you.
home, right? Yeah,
And do you remember how I reacted?
yeah, I do.
It's scary. It feels
Yeah,
like you're standing on emptiness. It's
yeah, yeah. Actually, and we can explore or experience you know
yes.
different things that weren't accessible if that technology wasn't didn't exist.
Yep.
So we can feel what is to be like being in a horror movie, being the main actor in
Hmm.
a horror movie. I remember, I think I put on the Emily Wants to Play game, something like
Yes.
that. Yeah, that was not nice from. Yeah. What's ICD and what's its digital technology? I think we must address that question first. Well, those questions first. First of all, I'll let you. I'll be transparent about it. I do not like the ICT term, as well as the French term, which is TIC. Well, TIC,
Hmm.
because it meant that information and communication technology. But well, if we think about what technology is, from a semantic point of view. I don't know if I can say that, but um, technology means everything that's you know created to achieve something, a goal, like a hammer. A hammer is considered as a technology. Um, not everything. It not only includes um, all the digital things, but everything that's considered as a technology, like a pen is a technology, shoes is technology,
So
you
a
know,
tool that was created
yeah,
to make life easier,
yeah,
basically.
exactly,
Mhm.
exactly. So that's why I do not like the use, and especially in our era, because we'll see later, but technology and digital are not exactly the same.
Mhm.
So basically, what ICD means is information communication, or informational and communicational. I don't
Mhm.
remember, but this is not the only it doesn't refer to that at all when it comes to digital technology. Yeah, so I asked the question when, because humans are desperately looking for that moment or that person, who or she or he was the first to invent, to think of something. We like heroic histories. Remember all those history movie that you watched. Saving Private Ryan is the one that comes to my mind. Um, it tells a story from a person, not uh, an era or a human or a society. We desperately looking for that history, heroic it's history. So I asked that question because people want to know that, even though it's not that important, but still. So yeah, we're looking for the first to invent it or to think about what's the first digital technology. Okay, forget about ICT. I'm going to talk about this digital technology from now and on. Who was the first to invent the digital technology? Well, in fact, we must address another question before answering who. We must ask what is digital technology, as we just did with ICT. So okay, if you insist, let's try to find out who was the first human to create. Yeah, I love to put memes in my presentation. So yeah, so yeah, who was the first human to ever created a digital technology? And now I'm using digital technology because there's a somewhere in our history, human history, where digital era started.
Yeah.
So well, so by trying to find what was the first ever digital technology created, but first, what can be considered as a digital technology? So I might ask you, Alex, what comes to your mind? Yeah, but there's no there's no wrong answers or stupid statement. Don't worry about it. This is more like an uh, rhetorical question more than
Okay.
a true question.
Well,
Yeah.
if I think of the first technologies, I'm trying to think, um, because it could go as far as just making cutlery, like utensils and stuff, if you, like you said, well, no, you mean digital. Okay, so
Yeah,
we're further down.
digital.
Um, would it be the first camera then, or am I too far?
I think you're not going far enough. Yeah.
Not far enough, so further than that.
Like, I mean, what digital means to you?
Digital, hmm. When I think of that, I think of something that, well, that's why I thought of the camera. I think of something that captures an image and projects it as something else.
Okay. Okay.
So,
So,
first thing that comes to mind for me is that.
okay. So, regarding that, the Wimetoscope. I don't know if you ever heard of it. Heard of it? Which this should represent the first digital technology for you because it has the capacity, sorry, to project an image, right?
Yeah.
Okay, so for you, digital represent capacity of things to project or to be able to see images with with those tools. Well, actually, digital. I didn't make research, but yes, I did, but well, never mind. Digital. If you only look at the Wikipedia definition, digital usually refers, sorry, to something using digits.
Oh, makes
So
sense.
yeah, makes sense. And yeah, obviously digits. And which digits you think is mostly used in digital technology? Think of binary system,
Yeah, well, 0, 1.
0 and 1. Yeah.
Yeah.
So what if I tell you that everything that's digital technology is using the same digits, the same binary digits system. Everything. Think of everything technological out there. Everything that using microchips to transfer informations. Everything's that's everything that's wired to the internet. Everything that's connected to the internet. Actually, the internet itself actually uses. And Dave can tell me if I'm saying wrong things, but I don't think so. But yeah, so everything that's connected to the internet actually works with zeros and ones.
He is far, but I will confirm that with him. But I'm
All
pretty
right.
sure that you know your stuff enough, so I'm going to believe you.
Yeah, and if you don't believe me right now, that's alright because that's all part of the arguing process. Because I start with a statement and I defend it all the way through the slide number 54. So yeah, we still have a long way to go. So yeah, everything that's connected to the internet and even things that are not connected to the internet. For example, the first budget. the first gadget ever created. You remember
Oh yeah.
that that
Mhm.
that
Pagers, yes.
yeah, pager? Yeah, of course. So the first pager is actually the first technology that uses the binary system. Well, the second technology actually, but we'll get to this. So yeah, and everything works with zero, starts with 0 and 1. If I can make a comparison right there to make sure that you guys really understand how binary system is important in our life right now, um, I can say that binary system is to technology what carbon and oxygen are to human beings. So there's no life without carbon and oxygen. I think this is something we all know, and there's no digital technology without 0 and 1. So thanks to people who invented digits. I don't know who they are, but thanks to you. I don't know if it's the Greeks or Roman people, but thanks to both of
Might be
you.
the Egyptians.
Might be the Egyptians as well. Yeah, of course. So thank to you guys. Because of you, I can know when my where when my clothes are dried. So uh, yeah. So yeah, let's move on. So first, what can be considered as a digital technology? Well, everything that uses 0 and 1 um, to in
But
order to transfer information. Yes.
I have a question. How
Yes.
can we know? Because you say that everything uses 0 and 1, but how can we know for sure if that's the type of technology?
Well, actually, well, because actually, it's people documented their works when they invented
Mhm.
stuff. They explain how they do some, but you will get a more comprehensive. I do have a little example, 2 slides from here, that really represent how do we know that everything. And it took a little while also for me to understand how those digits are, how does it works, because yeah,
Yeah, how to
it
understand
cool
the
to know.
system.
It's cool to know, but well, if I don't know how to understand, I might won't fully be convinced about it, even if it's fact. um yeah. So but first, what can be considered as in digital technology? Digital has a polysemic multi-layered term. um I'm don't I don't really know how to explain that in other words. It means that digital have means more than only one thing. That's what polysemics means.
So
Multi-layered. Sorry.
semic, I'm sorry, I'm trying to break down the word because
Yeah.
poly means many,
Many.
but
Yeah.
the semic part.
Oh, I'll try to poly polysemic. Um. Yeah, capable of having several possible meanings. So yeah,
Okay, so versatile basically.
yeah, yeah, versatile, but in a semantic way. Like,
Yeah, so patterns.
yeah, yeah, exactly.
Okay,
We can say that.
interesting.
And multi-layered term, qui a plusieurs couches.
Multi-layers means yeah, multi-layers, literally.
Yeah, literally that have more than one layer. So we will get into this in a few moments. And most of the time when we talk about binary system, yeah, the common image. Yeah, let's make a little fast Google search for uh, digital. What I said, digital um, te- technology. Yeah, let's try digital technology. And the first image that comes, okay, this is not 0 and 1, but the first thing that we we have in mind when you talk when we think about digital binary digit system is 0 and 1 basically. And if I ask you again, Alex, what do you think 0 and 1 means? And
Well,
you're allowed to ask Dave's help for this one.
I feel like I might look slightly uneducated, but I'm going to try. Um, Technology like that isn't my strong suit for the details,
Yeah.
but I would say if I have to make a wild guess, zero would be the absence of data, for example, and one means that there is
Okay.
uh, like a number of something. So
You
basically,
you're you're not far away from it actually.
if you
You're
think
pretty
of like
close. Yeah.
on-off type of thing,
Yeah.
yep.
This is exactly how this works. Well,
Ooh,
actually,
I'm smart.
think of binary things that drives our life. What can be binary in our life? If does good and bad are a binary system because there's actually two opposite things, good and bad,
Yeah.
moral and immoral.
Mm-hmm.
There's light and right, sorry, and left wings when comes to
Oh yeah.
politics.
Or
A
just
lot of
day and
things,
night,
yeah,
things like that of
yeah, a lot of
opposites.
things in our life are actually binary. A lot of our way to represent things, it's using a binary system without even knowing it. And the most common binary system that we use is true and false. A thing can be true and a thing can be false. It cannot be like people, Fox TV people like to call them alternative facts. There's nothing
Yes.
as such, by the way. Facts are fact or they are not fact, so they are basically true or not true. Um, so basically, it started with a guy. I don't actually remember his name. Um, George Boole, Boole. George
Huh.
Boole, with Boole is a last name. Actually stands for Boolean. Uh, yeah, Boolean, which means actually I don't know exactly what Boolean means, but it means true or false. That's Boolean algebra. He's the first to ever thought about the Boolean algebra and the true and false thing. So,
Huh.
in what year, you may ask me? Um, 90, no, sorry, 8080. Yeah. Since 8080, human society have, discovered, let's call that, let's say that, discovered the binary system. So he basically invented a Boolean algebra, um, this logical way of comparing numbers to make decisions that produce either a yes or a no, or sorry, no, a one or zero, a true or false. So this is called Boolean algebra, and binary digits actually uses that, you know, invention or that mathematical way of thinking or of viewing things as true or false. Life is way more complex. Human societies are way more complex than simply zero and ones. But if you want to understand technology, digital, sorry, technology, um, you have to start with that binary system with zeros and one. Sorry, I didn't uh, turned off my Facebook noise. So yeah, um, where was okay, cool. Characterized by the use, sorry, no s, of binary digits when representing transmitting information. So we'll get into this in minutes. So can we really communicate by only using 0 and 1? Actually, yes, we are at the moment. As we speak, as I send, information, vocal information to Alex and to everyone that's viewing us or listening us on YouTube, everything that's digitally send uses the 0 and 1 process. So can we really communicate by only using 0 and 1? Yeah, of course, we actually are at the moment, and most of the time we're in interaction, sorry, with those two digits. Um, so yeah, basically a system that we didn't even know the existence 15 minutes ago drives our life since 1949. Congratulations. So, so I asked the questions myself because I really like complicated things, um, especially when it comes to my life. So why do not adding new digits? Why not adding new digits? Yeah, later in symbol wouldn't be you know simpler to
Simpler.
simpler yeah to just let's introduce 0 1 2 3 4 5 6 7 8 9 A B C D E. Can we do that for a system, for example, programming computer to make sure that when you press the A button, it writes an A. So he's sending an A information. So why not adding new digits, letter, or symbols? Well, as Alex answered a few moments ago, 0 and 1 stands for true and false. Can we have
Sure.
another variable? Variable? Yeah.
Can we have another interesting. Yeah. Let me do a quick search.
Variable, I think. Yeah.
I'm looking just to make sure.
It's like,
Yeah, it would be variable.
variable. All right. Can we add new variable to a true or a false answered statement? No, because like I said earlier, something can be true and something can be false. It cannot be half true and half false. Um, I'll take a sentence as an example. um, Well, let's say that Alex is my mom, and she asked me to. Yeah, I'm trying
I'm not
to.
that
Yeah.
old.
So because she's older than me, she will play the role of my mom. So Alex is Alex is going to be my mom, and she tells me. She asked me actually if I did my homeworks. Let's say that I'm a high school student. Um, and I do not do my homeworks because yeah, that's what I was when I was 15. So yeah, so she asked me, "Did you do your homework?" And I say, "Yes, I did my homework." But considering the fact that the statement is not true, so a certain a particular consequence will comes with that statement. Um, what if, for example, I did my English homework but didn't do my mathematic homeworks? Does this mean that statement is half true or half false? No, because I said yes, I did my homework, but homeworks mean mathematic homework,
Mhm.
history homework, French homework, etc., etc. So that statement is still not true. But if I want to be more precise, or if Alex want to be more precise about the question she asking me, she would rather ask me, um, did you do your mathematic homework? So yes, I did. Did you do your English homework? No, I didn't. So this way I can be more precise about questions and response and answer, sorry, that I give to those questions. And that's exactly how binary systems are working. So let's say, for example, well, I think I do have a more, yeah, iconic representation. There you go. Um, there it is. Because with digits we can even represent pictures. Do you remember where this come from?
Wait, I can't see it yet. There is a delay.
Like,
For those who didn't know, there is a 15
oh,
second
yeah,
delay.
sorry,
So, yeah.
sorry.
Okay, so isn't that Space Invaders?
Yeah, exactly. This is Space Invaders.
Mhm.
Little square are actually pixels, okay? And there's, well, if we can see pictures as lights or, bulb or candles or whatever that makes lights, um, we can represent them as on and off, right?
Yeah.
So, blank or white squares are basically on, and darker squares are basically off. So I can tell by assigning 0 and 1 to every single pixel that's in my screen right now. I don't know exactly how many there is there in your in modern screens, but it's a lot. So basically, each square represents a pixel, and let's say that I want to draw that picture. I have to um, you know, put some 0 for, on. Let's say the blank square, sorry, are on, and the darker space are off. So 0 mean on. I put zeros everywhere that's blank squares, and I put ones into the darker area.
Mhm.
So this way I can create a picture, an image, letters with those, and this is exactly how the 0 and 1 digit format actually is used for. Hang on.
So we've been doing that as kids with Light Bright without even
Yep.
knowing that
Yeah.
we were using a
Yeah,
binary
exactly. We've
system.
been doing this actually during all childhood with light brights without even knowing that we were playing with digital binary system. Yeah, how bright we were, you know.
The 90s
Uh,
preparing us for the great era of technology.
yeah, exactly. Oh, I skipped. There you go. Zoom out. So yeah, you were actually right. This is Space Invader, from 1970. One of the first video game ever created. The first, this is arguable, but people say that the first being Pong. So yeah, we'll get into it for during class number 12 or 11, something like that. Yeah, we will discuss about video games.
Yeah, discuss video games. Cool. Okay.
Cool. And then we'll be able to create this. So here we have yellow and white and blue and dark, areas, simply by assigning different combination of digits. I'll insert table. This would be way much easier to, let's say, 4-row layout. Insert left. There you go. 4-column there. So let's say that yellow, we have yellow, blue, white, and black or dark or whatever. So let's say that yellow is represented with 0 and 1, with combination of 0 and 1. Blue as well, white, and black. So we do have different, I'm only using 0 and 1 here, okay? And I'm representing different colors with zeros and with 1. The order is actually really important. The spacing between those are also important. So this way I can easily create any pictures that only uses yellow, blue, white, and black. And if I want, I can also insert another color, let's say red. And, well, no, it's already taken this as well. Oh, dang it. It's all the digits, all the combination have been already been taken. So I have to add actually a new digit to it. There you go. Simple as this. So now I do have 999 possibility. No, sorry. I have 3 by 3, 9. I think I have 9 different possibilities, right? 3 by 3, 9. Okay, maybe. Um, so yeah, 0, 1, and 1. Let's say. So this is red. And I want to add another color. Let's say pink. This would be 1, 0, 0. No. Actually exists. 1, 0, 1. So every time that I want to uh, color the pixel in pink, I will have to enter in that square, yeah, 1, 0, 1, which stands for pink. So that information is sent to the computer that actually projecting into our display system pink colored pixel. Um, is that understandable how binary system works actually?
I think it's clear.
Yeah. Okay. Cool. This is my main concern at the moment. I just want you to understand how does this work. Okay.
I mean, it's a
Um,
system that's complex in itself. So even if people don't understand that system, I don't think it's your fault for the way you explain it. It's complex enough as it is
yeah.
in its
Actually, it is.
nature.
It took me a while also to really understand the true, you know, fun, the fundamental, uh, um, the foundings of this system, binary system, and then we'll be able to create this, like I said, to this. Okay, this is an Assassin's Creed, sorry, picture, new Assassin's Creed picture, which is actually really complex. You'll see that there's not only different colors, but they're different tones, they're different shape, they're different texture, there's different, you know, everything that differs from a pixel to another uses a different digit uh, system. I don't know exactly if, well, I don't think that people actually entered zero and ones all the way to create that picture, but the computer used to generate by itself zero and ones in order to communicate with itself, to send actually informations um, to the users, or the person that's creating the picture.
So
Sorry.
it's sort of like an HTML language or another language like that, but instead of using actual letter characters, you're using those two digits.
Well, the comparison is kind of it's interesting, but in fact, it is even more deeper than the language. If you want to make a comparison, sorry, with the with English language, for example, let's say that you know, 0 and 1 are um, oxygen that let the sound go through the atmosphere, and you know, from my mouth through
Hmm.
your ears. Sorry. So yeah, that's more, you know, fundamental than simply a language. As you said, which is right. HTML is a language that's using, you know, different norms and different standards in order to, you know, have a complex and comprehensible structure. And 0 and 1 are the you know, the digits binary system is what makes possible to represent that language on our screen. That
All right, so
make
in order to have HTML, you need to have the binary system
Yeah,
first.
exactly. In
All right.
order to even, you know, be able to interact with anything that's computer based, technology is, yeah, actually using digits. For example, I press the A key right here. I press the A key. I'm not sending information to my computer that, yes, I do send an information to my computer and say, like, hey, can you print an A, please? Yeah, I do say please to my technological tools. Um, yeah, I do have a funny story about this later on. So yeah, I do send an information, and basically the what's inside the machine. This is actually the what makes the communication possible between me, my computer, and it within the computer itself. It's actually electrical signals that's allowed or not allowed by using of the binary system. For example, I press A, signal that's sent to my computer using transistors that opens different gates, true and false gates that allows the electricity to go through different system, different uh, pathway, and tells the computer that I wanted to print an A. So there's a lot of there's a complex system between everything we do with computers and digital technology, uh, and this this binary system is actually the carbon and oxygen of human life. For technology, it's as important as this. So
So they're
yeah,
vital. If you don't have that, you don't have
you
the
don't
the
have
technology.
we don't have technology that we have today. If there's if it's not if it was not for uh, because Bull in 1988 1980, sorry, uh, well, probably someone else would have invented it, of course, but we couldn't be even able to have this discussion this morning. So yeah, well, so we may define digital technology as, well, technological tools built upon binary digits system. So cool. Well, so what's the first ever digital technology ever invented then? Um, my PowerPoint slides are a little bit in a hurry to know answer that question. I'm not going to ask you that question because for obvious reasons, it's way too. I don't think there's a way that we might know what was the first ever digital technology ever invented with uh, that uses the binary digit system. But but
No, but maybe ask the question in a few classes. That could be
yeah,
interesting.
yeah. Um, there's actually four people, including your TV, to be connected at the streaming live right now. So
I think you actually have comments in
yeah, I did answer them.
in
Mary just tell me that your questions actually helps for the comprehension. So keep doing your
thank you.
good work. Keep doing your good work. If it can considered as working for you right now. For people that don't know, Alex and I are longtime friends. Well, we can say long time, right?
I think so.
It's not the
It's getting
first.
there.
Yeah, it's not the first time that we've been working together.
Nope.
That we've been teaching together, yes, but not working together. Well, let's go back to to our main topic. So yeah, what's the first ever digital technology ever invented then? So by this I mean the first technology that uses the binary digit system. It's actually transistor. And I made a jeu de mots. I don't know what call it. Tongue twist.
No, not a tongue
No.
twister. It's just a wordplay.
Oh, wordplay, simply like that. Okay, I made
Hmm.
a little wordplay with that. A switch for a digital revolution. Which cannot actually be more true than that. True than that. So, well, the first ever. Well, regarding all the stuff that I've read and things that I know about that technology. You can also ask Dave for this one, but in according to what I found, the first ever technology digital technology, sorry, was the transistor. Do you know what a transistor is?
Transitor would be
Transistor,
a
which actually is,
transistor
yeah,
like a switch,
yeah,
literally a
this
switch.
a literally, yeah, a switch for,
Interrupteur in French.
yeah, exactly, un
Okay, it's like a
transistor.
light switch.
Yeah, it's basically
Okay.
like a light switch, but a little bit smaller. Yeah, a
Okay.
little bit smaller. Do you know how small is the what's the length of the smallest transistor ever created by human beings?
Mm.
Do you know what size? That's a tricky question.
Smaller than a grain
Yeah.
of sand.
It's actually 5 nanometer long.
It's pretty tiny.
Yeah, it's I wrote it down somewhere. Yeah, some transistors now they can be as small as 5 nanometer long, and that two strands of DNA.
Wow.
So yeah, we've come to this. This is kind of scary, but let's go back to this, and this is why also we do um, oftenly compare a computer to a human body or human system, because it works actually in the same way. Uh, yeah, with all the information that's going through from our brain to execute some of our movement, or some of our thinking or whatever. This is some, a good comparison to make. We'll try to do so.
And it makes sense because
Yeah,
that technology is mostly used by humans, let's say.
yeah,
So
exactly.
you
So,
need something that's going to
uh-huh.
mirror our
Yeah,
intelligence.
yeah, and so we can comprehend, well, at least if we take the time to, how it actually is, it is actually working. So, yeah, what's that? Basically, as Alex said, is yeah, it's a switch. It's a switch because do you know um, how electricity flow works? If not, don't worry about that. Me neither. But the thing, yeah, but the thing that I know about electricity, it's really hard to to maintain very precise level of electricity flow. I can, for example, I can pour water from a water bottle, reusable water bottle, of course, into I don't know, another recipient, and I can control actually, the flow uh, of water that I'm pouring into the other recipient. This is not exactly the same thing when it comes to electricity. Um, we didn't, well, before that, transistor thing, we didn't have, the resource or the tools to actually control electric flow. When you have an interrupter in your house, you switch it to on, and the lights, the bulb actually produce lights. But when you turn the switch on, you don't turn the switch halfway on. I don't know if you can, understand what I'm trying to say right here. Is that,
Depends if you have a dimming bulb or not.
yeah,
But if
exactly.
you're talking about standard ones,
Yeah,
they would just be on and off.
yeah, exactly. And the dimmer actually is composed with a lot of transistor that allows the user, when sliding the dimmer switch, or I don't know how to call it, slightly on, that allows to produce less electricity, well, less light than if I uh, put the dimmer switch all the way to the top. And that's not because the dimmer controls the electricity flow into that. It, it doesn't control the electricity. It Let's say that electricity flow is not like gates that you can open à moitié, or you know that you can only slightly open. You open it or you close it. So by using multiple transistor that that for example we're using 7 transistor. I'm saying c'est n'importe quoi là, mais I'm using 7 transistor because I want to have 7 level of lightning in my dimmer switch. So when I'm on the first level of that dimmer switch, only 1 transistor allow electricity to go through. When I want to light up to level 2, there's 2 transistor actually that let the electricity flow go through, and so on and so on. So this is basically how an electric a transistor actually works. So this is the way that we found to basically control the energy that's going through a system, an electrical system, without sending too much or not enough power, and at some point to control the level, and with a highly precise level of control of that electricity flow. So this is what the transistor actually do. And for me, it is, well, for me, not telling that this is my opinion, but regarding all the all the findings that I've been doing for the last last days and weeks, transistor can be, in my opinion and some other authors' opinion, to be one, if not the technology that actually take us into a new era, a digital era. This is the transistor that allows us to to go in that digital era. So a little thing that we might never heard of is actually responsible for all the technology that we now have today. So if I don't know if I was clear enough for that transistor part. If you can, I don't know, Alex. Oh, yeah, May I lost connection with her? Oh yeah, I do lost connection with Alex. Sorry. Sorry. She told me that. Yeah. She just told me that her transistor stopped working, which is
Hi.
not. Hey there, your transistor did not send you enough electricity.
Oh, I can't hear you.
Oh, sorry. She cannot hear me. Hang on a second. And closing this, turn this off. Parameter, microphone sound blaster. Now she should be able to hear me. There you go.
Okay, I hear
Cool.
you. I'm on.
So yeah,
Yes.
this I do remember why I was telling myself do not close your Facebook tab. This is why. Yeah, I do remember now. So what I was saying is that I'm not quite sure if what information you missed out, but if with the information you have, did you more understand what transistor is and how it's working actually?
Yes, you explained it very clearly.
Okay, cool. Thanks. Because I'm not using much words, so I just want to make sure that those are appropriate to transfer the right information.
But I mean, it's once you get the hang of it, all you need
Yeah,
to remember is that 1 means on, 0 means off.
exactly,
So,
exactly. And when it comes to electricity, we're talking about um, proton and electron and proton. I don't know if
yep,
it's okay.
yeah, protons. Mhm.
Protons and electrons, which stands which for the plus and minus stands for. So
Yeah.
plus is obviously proton, and minus are electron, or the opposite. Well, that's not that's not very important actually. So yeah, it's considered transistors considered as the technological, you know, digital tool. That's the first ever, I think, in my opinions regarding all the findings that I've done around this topic. Appears to be the, you know, responsible for that digital revolution. Isn't that fascinating? Well,
I'm very fascinated right now.
thank you, thank you. Well, so who this guy is? Actually, his name is I do not remember, so I will take, you know, have a look on Google. Um, well, things that I know is that he's the first ever to invented what we call a pager. Yeah, sorry, pager
Transition.
is yeah, in French. So, he's the first to ever invented a pager. You know, the pager that not the pager that we use. Well, I can't say we used to to use, but yeah, this basically looks like a communication radio, and it was essentially relied on a one-way radio communication. And I'm not quite sure if we can call it, even though if it this technology uses a transistor to be able to transfer different type and different kind of comment to that, you know, that device,
Mhm.
but essentially relied on one-way radio communication. But this is the first technology, well, as might say, regarding my findings, that uses the transistor technology. And this was not introduced to grand public, to everyone,
To the great public,
to
yep.
the great public. Yeah, this was not introduced to the great public at first, but essentially used with critical use. Sorry, for critical communication. Let's think about, you know, fire workers, firefighters, police officers, and you know, all the radio that wi- and as you can see, this is wireless, so it uses, you know, radio tower communication to have a one-way communication with. Well, actually, I say one-way because it's, you know, from a central to this device, but I think it can also be the other way. This, you know, this might not be 100% true, if that's even possible. So yeah, around the 1950 in New York City, and a year later, actually, this is the most interesting part of the, yeah, Gross. There you go. The Gross's pager.
Yes, Alfred Gross.
Alfred
Or
Gross,
Gross.
exactly. I think it's it's pronouncing that way, but even if it was using transistor to work properly, Gross's pager wasn't exactly using a binary system in order to be functional. This is more relying on the same technology that uses radio communication, you know, and stuff like that. So, um, but do you know what does use transistor to work properly? We discuss about it. That question is not full complete.
Answer.
So do you know what does work with transistor in order to properly function? Yes, of course, computers. Exactly, computers, but not quite this model actually, but more like this one. That's more accurate. So yeah, exactly, computers. This is, well, authors says that computer might be the most influent technology, not only digital technology, but the most the most influential, yeah, digital and technology at large, to you know, that revolution that changes society the most for the past 70 years or so. So yeah, basically computers is the that's technology that has been the most influential through um, modern modern society. Um, is it the way to make it louder? My phone's volume is full, but I'm still very low. Yeah, of course, Stacy. Let me try to. Yeah, I can pump the volume a little bit up. Yeah, there you go. Should be able to be more clear now. Yeah, there you go. Okay, so yeah, computers. But why using transistors and binary system for computers? Um, what's the main source of power? I mean, that's really an obvious question, of course. But I'm asking you right now, what's the main source of power of computers? Uh, Alex, sorry.
Uh, Electricity, I guess, if we're going concretely.
Sorry.
Electricity.
Yeah, electricity. That's right. And like I said earlier, electricity is and more precisely electricity flow. This is not something that we can handle or physically, manipulate. So it's really hard to adjust the level and the intensity of that electricity flow that allows us to transfer information from a component to another in order to make the computer works. So basically, what transistors did to the computer is actually allowing the information to go through a different path within a system in order to communicate some information. You're welcome, Stacy. So yeah, basically, transistor allows us to control that electricity flow. I make a long story short right here, for obvious reasons, but yeah, transistor actually is the technology that allows us to control that electricity flow, and that allow us to also to make that information moving from a system to another. From example, from my motherboard to my processor, and within the processor itself, from a core to another core, from and so on and so on. Computers are basically made, and I'm not quite sure about that, but yeah, sure enough to put it online. I'm quite sure that computers are essentially made with transistors. So because this is what allows the electricity to go through the system and communicate information regarding to the amount, not the quantity, but the amount of electricity that's been sent from system to another. Is I don't know if that's clear enough for to understand how what's the implication of those transistors within within
Super clear.
computers. Cool. So this is the way that we found to allow computers to communicate with itself and with other computers, like we see on that. Well, not clearly see, but that we are able to see the links between elements on that logical map of the ARPA network, the ARPA network, sorry, most commonly called, well, during the 1970, of course, most commonly called the ARPANET. ARPA stands for Advanced Research Program of America. I'm not quite sure about it, but I know that I'm defining it later on during the presentation. So yeah, then taking the same technology and I'm talking about that binary system.
I have clarification if you want for the ARPA. It's Advanced Research Projects Agency.
Oh, agency. All right, and yeah. It have been developed in California, if I do remember well. well, we'll get into it more precisely later on, but basically, what I wanted to say here is that we're taking the same technology, the same binary technology, to communicate not only from a human to a machine, not only from a machine with itself, but from a machine to another machine, you know. So everything that's on the internet is, well, if you want to make it simple, just just remember that ev- all the information that are not physically uh, tangible, or that you cannot have behind your hands, all of those information that can be digitally stored or digitally transferred are using that same technology, that binary technology. All, all is made of 0 and 1. So when the next time you will watch the Matrix, enter the Matrix movie, and you'll see every 0 and 1 things when Neo's leaving the I don't know how it's called. Yeah, the Matrix, of course. Obviously, yeah, it's not that false at all. So to be able to send, well, actually, we're not living in Matrix. Don't worry. This is not a streaming about about Illuminati and stuff like that. But yeah, this is basically the same process without through the use of physical object like a floppy disk. So yeah, the internet, or something that follows the same principle, because the ARPANET network is not exactly the same thing as the internet. We also get into it later on. We try to understand how the internet works. Internet's not only made out of memes and cute videos of cats. There are also plenty of cute video of dogs out there. So and other stuff that might interest students, like information in order to complete your assignments and stuff like that. But most importantly, cat videos. Even if, yes, and depending on factors that affect socioeconomic situation, cultural background, etc., 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 the history may be different for every single human beings. As humanity has experienced yet 3 different ages. This is from Howard and Mosaico. Sorry if I'm killing your name, sir. But yeah, as humanity has his experience yet 3 different ages, as we call pre-digital age, a personal computer age, and the internet age. Those all of 3 ages are main component of the digital revolution, or the digital era that we've been living since, like I said, 1949 or so. So yeah, pre-digital age is from that moment ended at the moment someone invented the first digital technology, in my comprehension, which is we just discussed about it, transistor. This is my my timeline reference about ages, because when we're talking about history, we like to, I know historians don't like it at all, but we do like to split a different part of our history into different ages. So if we do the same thing here with the digital revolution, we do have the pre-digital age, that ended on 1949 or so with the coming of the transistor. The personal computer age that comes years or 2 later, in 1951, which, like I just showed you here, the first ever computer, the first computer to be ever created with the use of a digital technology. And finally, the internet age, and the personal computer age and the internet age are like overlapping. I don't know if I can say that. on each other. That means that the
Overlapping.
overlapping. Yeah, thank you. So the internet age, the personal computer age never really stopped. We're still, evolving through that age, as well as the internet age has made its apparition during, let's say the ARPANET in 70, 90, 70, or 68. We'll get into it later. So yeah, we're kind of right now we're living in a society of personal computer and internet age. Those two ages are the main characteristic of our digital society that we're living in. So yeah, computer being the most influential digital technology ever created. Ever created. The internet being not close, not far from behind that. So yeah, if we want to represent the three ages using the mailing system, let's say that pre-digital age is sending mail using a post device, post service. Sorry. Personal computer era is actually using floppy disk to transfer a digital writing or a digital mail, and internet era would be simply sending emails with the use of Outlook, Gmail, and other stuff like that.
And with emails as well, because now I think we're beyond that point, because
Mm-hmm.
people do still send emails, but we do live messaging as well, instant messaging.
Yeah, exactly. That's another part of the internet era, I guess. Like I said, we evolve in those two overlapping era, which is the personal computer and the internet eras, and we still, refining, if I can say so, all those inventions that made us, that introduced us to those two eras. So from the first computer to our, personal smartphones, which is actually a micro computer that's using the same, the same functions as in computer. Yeah, so basically we're just, getting better at computer and internet. Not better at using them, but you know, the technologies
Better at
yeah,
developing them.
exactly, better at developing. Which is funny because the developing rate of those technologies are going, is faster than our actual capacity um, uh, to do to study them.
To
So
adapt to them, yep.
yeah, so there's way less researches um, on personal computer and on internet that there is research about their implication and their role on as well on human body, cognitive and physical aspects, as well on society. Yeah. So yeah, let's firstly now it's 10:30 a.m. Let's say we do a quick break of, let's say, 8 minutes. Maybe is that long enough for you? Or maybe I can give you 15 minutes maybe. We still have a lot to cover up.
Sure, you'll just have to be quicker in the second part.
Yeah, yeah, obviously. Cool. So I'll try to be a little bit quicker in that second part, and let's say we hang on, new slide, um, insert a text box. Yeah, let's say that. All right, so yeah, we'll be back in about 10 minutes. So you can go refill your water bottle if you need to, go at a bathroom, stuff like that. So yeah, we'll be back at 10:42. I won't be able to hear you at that time, Alexa, by the way. So
Okay.
so hello to, I'm not quite sure that's your real name, but favorites mine. Yeah, I don't know if it's a student of mine, but welcome into the stream where we actually discussed um, the uses of digital technology in education. And today's class is about a brief history and how does how things are working, uh, how digital things are actually working, all those digital tools that we're using in our life. Um, so yeah, let me know if you're somehow a student of mine. If not, I'm Sam. I give this class for in order to ensure the teacher's formation to use the technology and all those technological tools um, in their future work. As you might probably notice, English is not my first language. So yeah, there will be, of course, some, you know, speaking mistakes as well as writing mistakes in that presentation. Sorry about that. And yeah, but all of those information, there's actually no mistakes in those information. So yeah, you cannot use your computer. You're on your phone and you don't see as well. Yeah, sorry about that. But this live streaming will actually be recorded and uh, 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 put in on my YouTube channel, so you can watch it back again, view it back again at any time as you want. So this is going to be the way that we are going to have this class all along the semester. So by using this my YouTube channel, so I will be doing some live streaming at some time. Sorry. And yeah, everything will be stored on my YouTube channel, so you can go back there and take a look at our live streaming. Um, there's also a 15-minute delay, 15 seconds, sorry, not 15 minutes, but a 15 seconds delay between words that I'm saying and the moment that you be hearing or viewing me. So yeah, basically this is. Hang on. I'll send the link to. So yeah, we will start. We'll be back in maybe 30 seconds. Let me just call Alex back so I can ask her tricky questions. Oh, there she is. Can he hear me? No, she can't. Oh,
Hello.
hello. Welcome back. Um, yeah, right on time. All right, cool. So have you had time to discuss with Dave about, transistors and stuff like that, or
He
decided?
said that I was surprisingly very aware of the subject, even though it wasn't my field of study.
Okay.
I have to say I'm impressed with myself for
Yeah.
knowing what I thought I didn't know. So, but it makes sense. It's logic. So,
Yeah, it's really, I wouldn't say easy to understand, but makes more sense in that way when take time to really go back and understand where this comes from,
yeah.
and how it was invented. So yeah, actually, I didn't say it, but the computer was initially created or invented, or whatever the word we decide to use, but in order uh, to intercept the Nazi messages during the World War II. So yeah, have you ever heard of the movie Imitation Game? I think that's how it's called. The Imitation Game, um, which actually
Yes,
is, yeah. Sorry.
with Benedict Cumberbatch, I think.
Yeah, that's the movie itself is you know historical inaccurate in some ways, and there's a love story that takes too many too much place, in my opinion. But yeah, this is actually the story of Alan Turing, which is the first ever to invented a machine that can intercept messages. A machine that do not use well, I think do not use transistor because it was invented years after, but uses the communication radio tower and stuff like that too.
Yes.
So I'm not quite sure it can be considered as the first ever computer, even though some authors are comfortable with that idea. Um, so yeah, let's say let's say that the first computer was invented in 1950, and we'll argue about that later on. So yeah, I'll try to mute my Facebook tab because it will be annoying. Quite sure I can do that, but well, that's okay. All right. So, oh, what was that noise?
There's noise also from my microphone that's coming out because
Okay.
of the
All right.
and the dog. I'm sorry if you hear squeaky noises. I'm training a puppy.
All
Sorry.
right.
Mhm.
No, no worry about that. So, yeah, let's move on with we talked about transistors that make able computering, and the kind of this sort of internet mapping thing, and transmitting information from computer to another without uses of physical physical tool. um, Où j'étais rendu? Yeah, so as we enter into the personal computer age around the first years of the 50s or late 40s, as I wrote down in this presentation. So yeah, let's assume that sorry, that the pre-digital era ended the year the transistor was born. This means the end of the pre-digital era, which is late 40s. And this also means that the society have entered the personal computer era. And to be more specific, on June 51, with the UNIVAC, I don't know how to say it, but and
Univac.
UNIVAC, yeah, which looks like some, control board panel sort of, with all those buttons. There's a keyboard, as we can see, but not clearly see, but yeah, there's a keyboard. There's also an image of flooring at the background, which I, I just realized. Yeah, that's very funny. So yeah, this is basically the considered by many as the first ever computer that uses the transistor system. Yeah, to control the energy flow that's going through different part of that computer. And since new steps will be taken with the uses of first computer with graphical user interface, which most commonly called a GUI. So every time you will see GUI, it stands for graphical user interface, which is basically a screen. Okay. So before that, Xerox Alto in 1971, there was no screen. actually. So we were sending information, um, and most of the time this was connected to some sort of a printer that will allow to, make a copy of that information or to be able to read or understand that information. But it wasn't displayed onto a screen like it was since 1971. Do you know how much this would cost in that day?
I'm guessing it would be pretty expensive
Yeah, about
because it's
yeah,
new technology.
40 G's actually, $40,000. Yeah,
A lot
$40,000
more
for.
than
This is way more than normal family can afford back then, and as well as nowadays. But this is the first, ever developed by some guy that working at Xerox. Just forgot his name. Sorry for him. But and at that moment, that company Xerox refuses to actually finance found that finding in at that time. Why, you may ask me? Well, it's kind of ironic because um, company Xerox was fearing to see coming a society where a paperless society. Yeah, because of the use of the graphical user interface. Now that we can see, that we can communicate with words on a screen, and send that information um, to other computers while using. What's the point of using paper then? So they fear that we come through a society without, the use of paper, which is, not what happened, but with all the um, cyber, uh, with all the newspapers going to digital technology, this is, a sort of effect and cause of the arrival of graphical user interface. Not this one, because they stopped developing it because they didn't have, well, Xerox didn't give the found enough found to keep to keep working on that tool. But someone,
fun fact,
yeah,
actually.
sorry,
Xerox is a well-known printer brand nowadays,
yeah.
so it's funny that they started with the monitors, the screens, as to eliminate paper usage,
Hmm.
but nowadays they actually go towards printing
Well,
on paper.
actually, they were fearing that the society will come into a paperless society. So that's why they stopped founding this
Ah,
GUI interface computer. They didn't want them at all to to introduce the homes, because yes, as you just said, Xerox is a printer company now, and yes, this is also ironic that you know their financial, their company is based on paper. So yeah, maybe it's uh, the reasons why. Then in 1997, wait, sorry. Then in 1977, the Apple II, or the second Apple, first ever commercialized personal computer to be equipped. Uh, Personal computer is stands for PC stand for personal computer, to be equipped for of audio cassettes. I don't know if I wrote it uh, uh, wrote it correctly. Cassette, yeah, I think I
yeah.
would call it audio cassette reader for saving data. So how does this work? Actually, I don't know. But the main principle was to encode the digital data into sounds of different frequency, in order to save some progress that you've been made on computer, and as well as to install program. So they were installing program by using um, audio cassette and an audio cassette reader plugged into that computer for reading and saving data. So yeah, not only for listening at Backstreet Boys, those cassettes were used also to read digital data. So he will be gradually yes, I said you read that right. I said he. You will understand in the next slide. He will be gradually introduced into homes and school because it's affordable and user friendly, as a user friendly interface. So I'm not quite sure this is the right, picture of Wikipedia in 1977 that we can see right there. Let me doubt about it, but this computer has the first ever, graphical interface that is actually affordable and user enough user friendly, and has an enough user friendly interface, yeah, to be manipulated by I don't like to call that way, but ordinary people, or people that were not usually used to work with computer programs and stuff like that. So and yes, you read that right. I said he or she. You can decide, of course. The funny reason for that is that because of the first time since its creation by Henry Lucy, I think I'm saying it right. In 1923, the Time magazine gave in 1982 the Personality of the Year award to a machine. Yes, for the first time ever, they gave this award to a machine, a prestigious one that many presidents have received, as well as many scientific like Albert Einstein and other influential personality. So this is actually a big thing, being named Personality of the Year for a machine. This actually means a lot for this society. Well, do you ever think this was ever possible? Um, while I take a sip of water.
Imagine being any type of other scientist or influential person, and the award gets given to a machine and
Yeah,
not to a human. That must have
yeah.
been very controversial.
Yeah, of course. It's really, tough for scientific ego, which can be actually really big. But yeah, that means a lot about this society, and this is expressed also. And I really like that cover because it expressed how we turned into, I don't know how to call it, but papier mâché into uh,
It's paper mache. We say it in French.
paper mache person, and with a computer that actually looks more more full of life than the actually human on that picture. So and it tells us a lot about that time, because and how the computer actually changed lives of people. I don't know if you remember the first time you had internet at your home, but it changes everything. From the way I communicate with my friends, the way I get access to some informations, the way and computer actually worked or have the same or a similar effect on human society at that time. So yeah, and another fun fact though, in 2006, that the same award was given to people in general. So it's you. They gave it to you. People who use social medias, especially YouTube and Facebook's users. So yeah, first time ever this award was given to a machine in '92 and to a digital, software or website in 2006. I think last year, Person of the Year was Greta Thunberg, if I'm right about it. Yeah.
Yep, she was.
Okay.
Probably the youngest one too.
Yeah, of course, of course. What, 14 years old, maybe? Yeah, that's young to being awarded of Personality of the Year. So yeah, now the internet age, because YouTube and Facebook are parts of the internet age. I was telling a little bit earlier that those two eras, those two ages, sorry, like the computer era and the internet era were kind of overlapping since we never ended one or the other. But before getting to YouTube and Facebook, we must discuss about the beginning, sorry, of the internet era age, or should I say the internets, multiple ones. Now we can really say that. Before we address the topic, what exactly is internet? What and how does it works? That's a very interesting question. I'm really, hyped about what you're about to answer to this question.
Are you asking me?
Yeah, of course I'm asking you.
Okay.
What? Yeah,
Um,
let's try something.
right. So I would say that net goes for network.
Mm-hmm.
So, um, a grouping of people or information, let's say.
Yeah.
Inter means in, so it's like being into the gang, I guess. Into the group of people being
Okay.
within a society, almost
Okay.
digital society.
That.
So all the information you can find on your social media, on Google, because nowadays there isn't any information I think you can't find online just by typing it
Yep.
in a search bar. Um, but that comes from somewhere. It comes from a pool. It comes from many little sources of information put together, a network.
Yep.
So that's my guess.
And that's a very good guess because actually internet was invented with the idea of connecting, well, not connecting people together, not yet, not at the first steps of the internet, which we discussed a little bit earlier, which was the ARPANET. But the idea behind is was to give the opportunity to people to have access. By people I mean the universities and government and the administrative people and scientists, to give them the access of different information, that usually accessible only via paper, a source of paper or tangible document and stuff like that. So um, um, I'm doing two things at the same time. Sorry. So yeah. But how does this work actually? Because well, we know that the internet is a way to connect two or more different computers together to a more institution. We're not going to get into really specific about the internet, simply because even I doesn't understand how does it how it works. But yeah, the foundings are the, I don't know what to say it, but the intention of having access to all the information. Uh, yeah, and this was actually invented during the during a Cold War context, as well as the Alan Turing computer was invented during World War II. The internet actually see for the first time of his life, let's call this that way, during the Cold War. Why during war we're seeing so many new technologies come to life? Simply because the founding is much, there's much more founding when you're facing another country into war. So government don't count money when it comes to investing into technology during war. So this is when the first version of the internet comes to life. But how does it work actually? Is it, you know, nowadays we just woke up, open up, turn on our phone and go into Facebook. We already connected to the internet. We don't have to unplug the phone line or something like that. We don't have to do complex manipulation. We don't even know how to send, how the information are sent between one machine to another, from a server to another, and stuff like that. So we'll address that topic for the next few slides. What exactly is internet and how does it work? Think of a mind map, okay? I'll show you back that image of ARPA network, which I think is the best representation, even though we cannot read what's written on that map. But let's see the internet like this. So every square or circle are represents a computer, okay, or a state, or machine that's connected, and all of those are connected, well, directly or not, to every others. But the connection between two machines is basically peer-to-peer connection. That means that you are connected to another computer to give them the information, and not connecting to a network where you can have access to all of the other computers' information. So if I want to, I do not have a pointer. Do I have? Maybe with laser pointer.
You
Yeah,
need to point.
there it is. Yeah. So let's say that my computer is that square over there, and Alex's computer is the other square over there. So basically what I have to do is send that information through that pathway, and send it first to this computer, who would send it to this computer, to this one, and all the way through Alex's computer, which happens instantly without even knowing that this is how it happens. But basically this is how the first ARPA network was working, is by sending from peer to peer, from a computer to another computer, and so on, until the message reach is a recipient. So, well, if you want to send secure data, for example, everyone else that's connected to the same network would have access to, well, if happens to be in the pathway of that information transmission. But everyone can access to that information. That makes network a less secure, that we less secure, but at the same time it was more secure that the net that we're using today. But basically the first internet, the ARPANET worked that way. So ARPANET was, like I said, the first internet, the first network that uses that kind of process, and years later we will see different networking comes into different industry, different institutions and stuff like that, and each network that were created had a specific function. Okay, Um, I can go. Yeah, I can jump all the way to. Yeah, there you go. As an example, around 1985, the first ever science-dedicated network used to connect research and teaching centers, as well as to transfer informations between university. So basically, right now we do know only one internet. Okay, think of Walmart right now. So internet right now is like a Walmart. But before the arrival of Walmarts in our society, we had, uh, a place where we can buy, let's say, a dairy product. Another place where we can buy bread. Another place where we can buy, different stuff, tools. Another place where we can buy electronics and so on. So think of all of these networks uh, within the next 20 years, passing 1970. So the multiplication, evolution, and fusion of those different networks, but those different networks were you know were meant to be used in different contexts. For example, for defense communication between states, between two countries, using a different network than the network that was used by universities and scholars at that moment. So this way, it can ensure you know the secure part um, of the information, for the information that was transmitted between a computer and another. So this way I cannot, back in those days, I could not go into harpnet from my personal computer at home, simply because I didn't have a wire that connected me to other computers that were part of that network. So it may be confusing to understand, because nowadays everything is connected with everything, and we do only talk about internet in a singular way. But if we have to think about multiple networks, we must always have in mind that each network have a specific function, and were used by a certain amount of people, and were not accessible to everyone.
I
You know,
think it's safe to say as well that computers and, well, the net in general was reserved to maybe only the elite.
yeah,
So a specific type of people had, well, that sort of money, because
yeah,
if just one screen was thousands of dollars, people could not afford that. And to have the special connection, that special line, like you say, to reach the other,
hmm,
well, desktops, the other computers.
yeah,
So only a small percentage of people had access to that type of information, let's say.
yeah, yeah, exactly. And after that peer-to-peer connection, with each other, where the information can be accessible for, every other computers that was connected to that network. We didn't have, routers, which actually works like, microcomputers, where all the signals are going to that router, and all the information that I want to have, I go, you know, grab them from that router, and everyone that's connected to that router actually communicate with it to gain information, and not directly from with another computer. So um, there you go. Okay. So yeah, think of a mind map where every computer can be connected to anyone else's PC. So I said open a mind mapping software, please. So I tried to download a mind map software, but it was it was too complicated, and I tried to do it at the same time, but couldn't be able to do two things at the same time. So Yeah, that's why. I think that those explanation was still clear enough though. Um, so yeah, personal PC send information the same way we call people. This is another way to see the internet. Back then, the ARPANET time, it's by knowing the recipient address, or in that case, the phone number. Now, okay, you would say that, yeah, we don't have to remember phone numbers because they're all stored in our smartphone. Yes, but think when we didn't have smartphone. Okay, we had to put in carnet, a little,
A booklet?
yeah, we had to keep in a booklet some, phone calls
Oh,
of
a phone
person.
book.
Yeah, phone book. Cool, thanks.
A
Uh,
personal phone book.
yeah, a personal phone book that we used to store all the phone numbers of, our friends, family members, and other important people to us. So by knowing the recipient phone number, we were able to call them. Okay, I don't think I'm learning anything to anyone here, but how PC communicate with other PC is actually the same thing as we used to call people back in the day. So, for example, I want to send document to Alex's computer. So I need, prior to that, I need to know what's the computer address, what's the Alexa's computer address, in order to send that message to her. And also, she had to be connected to the same network, so the information can go through, wired computers. So yeah, and that's the Internet Protocol address known as IP address. So if you wondered what IP means, it stands for Internet Protocol address. So this way we know exactly which computer belongs to who and where it's located on a geographical scale. Yeah, on a geographical map. But before we address the topic of internet, what? Okay, I do and I've answered that question. And all the information must go through network. Otherwise, it will be impossible to be connected to multiple people at the same time. So, like I was saying, the ARPANET is cool because we can send information from computer to another computer. But what if I want to have access to a computer, to an information, without needed to ask to another computer and to send it to me, because this is how this worked. It's by using first the same network and to store all the information on a main computer that every other computer will have access to. All right. So people back then they think about okay, we can send information from computer 1 to computer 2, but what if computer 1 and computer 2 want to have access to the same information at the same time? Because it wasn't possible, just like phone calls, it wasn't possible for computers to communicate with more than one PC at the same time. So they think about it and thought that it was maybe a good idea to put centralize all the information on one main computer, which actually is the internet as we know it, which is multiplication of one central computer, because there's not enough space for one computer for all those stuff that we found on the internet. But what if this one computer would be the main, provider of information, and everyone that want to have access to that information simply have to, ask that computer to give them information. So this is exactly what happened in 3 slides. So yeah, unless you want to individually, connect your PC to other computers. Networks are fundamental when it comes to the internet. So the first one was the ARPANET, Advanced Research Project Agency Network. And within the next 20 years or so, we saw fusion, evolution, multiplication of networking as the need of information access was growing up in our society in that Cold War and Vietnam War context also as well. So yeah, like I said earlier, as an example, around the 55 year of 55, the first ever science dedicated network, which was the NSF net, which not safe for net, but National Science Foundation, something like that network. So yeah, what was the first let's say first web page to ever be created? Because if we go back to the first slide, we discussed about our need to know who was the first and what was the first to achieve something or to invent something. So around the 90s, Tim Berners-Lee invented the graphic version of almost the internet as we know today, and he called it the World Wide Web. Yeah, that's kind of hard to say. I prefer using triple W. So yeah, the triple W stands for World Wide Web. His main intention was to connect all of those networks. Like create a big Walmart where everyone can give information to anyone else. And he said, well, what if every computer was connected together at the same time, and what if they have access to all of the information that we have today at the same time? So yeah, so the main goal was to give an instant and universal access to a large amount of information to as many scientists and institutes as possible. I did find a graphical version of an interface that actually respond the same way that the World Wide Web project worked, actually. So I wasn't able to clearly read what was on my display yesterday, so I don't know if it's going to work well today. But when we go to that webpage, let me just open the link first. I think it's the second one. This is really cool. I don't know if you guys find it cool as well, but this thing that really, that really turns me on, that kind of technology. There you go. So right here we are on the first ever web page to be ever created. Yeah, in 1990, if I'm guessing right. So yeah, like I said, we cannot read well, but I did make a print screen to make sure that everyone can see what's on that page. So basically, when you go to that page, it says that the W3 is a wide area hypermedia information retrieval initiative aiming to give universal access to a large universe of document. Everything is online about W3 is linked directly or indirectly to this document, including an executive summary of the project, mailing list, policy, November W3 news, and frequently asked questions. So you might wonder what for what stand the numbering between those crochets. I don't know how to call it. For example, the number 2 just after the summary word. So basically, if you want to go to summary, the thing that you had to do back then is to type 2, oh, sorry, 2, and press enter. So this way it will load another page where you have other information, and it can lead to another path where you can choose different ways in order to navigate through the web. So everything was linked together, like, you know, think of a spider web where every pages are directly and not directly linked among each others. So it could be a little bit confusing for us because we do not understand how, you know, how to use that language, or how this how to use this interface. But basically this is the first ever web page that was ever created by a human being, is this one. And we, because of that, the technology that we have today, be able to retrieve that, you know, that first experience of 90 scholars trying to look for information on the web. So yeah, this triple dot brackets. Yeah, thank you, brackets. So yeah, and yeah, it was intended though. Um, Sorry if I'm responding to Alex while she is writing me messages on Facebook. So I don't know. I'm not quite sure if it was, you know, enough understandable. Trying to figure out what was the looking of the first web page. Another. Yeah. So this is the, you know, HTML version, which is way more, you know, instinctive, where we have instead of entering numbers, we can simply click on hyperlinks to, you know, load other pages, you know, and go through all the pages simply by clicking, you know, hyperlinks. So this was the second version of the internet. So yeah, the W project uses a specific language, the hypertext markup language, the HTML. I'm not going to go in details with for HTML, but simply to let you know that this was the language that they uses to, you know, be able to find the right and the right information when we type, for example, HTTP //www.google.ca/fr to make a research on the web. Yes, nowadays we simply have to enter keywords into our, you know, that URL blank space that we usually use for to reach website. But you know, we had to. I do remember having to type www.google.ca in order to go into Google website. Now you can simply enter keywords in that research bar. They also use a specific protocol to transfer information between computers connected to the network, the Hypertext Transfer Protocol. Yeah, I'm not going to explain that because I don't even, you know, clearly understand it myself. And also they use a specific address language, as I just mentioned earlier, to be able to find the emplacement of the information that we're looking for on that network. The Universal Resource Locator, which stands for URL. So that's the HTTP www.google.ca that we can see. This is called the URL. So if I wanted, for example, get some information about, I don't know, about let's say computers. Yeah, why not? I want to have some information about computers. So I need to go on a website to look for information about computers, and I do have to know the exact address. Okay, there was no Google at that time. There was no searching engine to make sure that you find the right website for your needs. Everything was was able with the using of pathway with between different links and different hyperlinks and different address in order to find that information. It might take more time than it would take to just go at the library and find for a book or about a similar time. But this the first the start of the triple W project at that time. We're talking about the early 1991 until 93. So yeah, are you still here, Alex?
Yes, I'm here.
Yeah.
Sorry, I'm
Okay.
muted because there's a lot of noise on my side.
Oh, okay. Cool. Thank you.
I'm not
What was?
responding because you're so clear, so you don't need
Oh,
me right
really?
now.
I was asking if I was clear enough. So,
Nope,
all
it's
right, cool,
perfect.
cool. So if everything's understandable, let's say it that way, let's move on to 1993, where CERN, which the let's say the triple W owner of the conceptor of that triple W, decided to give public access to the triple W software by releasing an open source license of the project. So every other company that interested into that project can use the technology or the way of connecting things to create their own network. And this is where was born. This is when was born the internet provider services. Okay, so for example, let's take AOL, okay, which stands for America Online, which I think was one of the first internet provider in North America, but not quite sure about it. But yeah, the so AOL was a service that uses that same protocol, that same technology as the triple W developed by CERN, in order to give access to homes, to give internet access to homes. And what it does, it does that. For example, take AOL. It has a main computer that everything on the internet is stored on, and everyone with the access on that network, on the AOL network, also have access to that computer that is connected to other computers of other uh, internet providers. So at that moment, providers were all connected together, and information was, directly connected or centralized at the same, basically at the same place. So everyone that has access into internet by the use of internet provider had the same access as another person that's connected to another internet provider computer. So I'm going fast with this right now, but let me show you today. And since this moment, internet never stopped growing, and this is true. Actually, there's I don't know how many internet pages there is in the world right now, but if we can have, I'm quite sure if that's clear enough. Let's see. Okay, yeah, this is actually the universe, but the internet universe. Each color stands for a country, a different country, where the information of certain websites are stored. Okay, for example, those big, cyan dots. I think that's the right color. Cyan. Dots are,
Cyan,
yeah,
light blue, yes.
yeah. Or for other people, it's blue. So yeah, all of those dots, some are bigger than the others. represent a website. That's, you know, a website that all the information are stored in a computer that's physically based in a specific country. And the closest dots are, you know, for example, the here. That's funny. That's AOL. That was not intended though. For example, we take that AOL dot right here. AOL.com is you know, that website is stored in a computer that's geographically located in United States, and that website is connected to, you know, other websites around it. So AOL sorry, .ca, which .ca stands for .canada, is a search engine for Canadian user, which ranked 54th among the most visited website in Canada. So the bigger the dot is on that map, the bigger the traffic it also is. So that means that the information that's transferred using these websites, the more dots, the bigger, yes, the dots are, the more transfer it happens at the same time. So I just realized that I'm running out of water. I forgot to refill my bottle, so I'm just going to quickly do that and think about that map and how big it is. I'm about to ask you a few questions in about let's say 3 or 4 minutes. I'll be right back. Sorry. Okay. Whoa. Hang on. All right. Can hear you now. So, welcome back. Alex, what the first thing that comes to your mind when you see this internet map?
Well, it looks like a galaxy.
Yeah, exactly.
Yep.
Exactly the image that we all have when we see that map. And actually, like universe, well, depending on which scientific theory you base your beliefs, but basically, galaxy keep expanding. You know, universe keep expanding every second. This is the same thing as the internet map. Okay, it keeps expanding, but instead of expanding within the the external part right there, um, it will expand from the inside. All right, dots are growing bigger and bigger and bigger, and multiplication of dots that going to appear among this web map. I was also going to ask you which well, I gave the answer a little bit earlier, but what website stands for those four main dots that are represented here?
Which websites? I guess I didn't follow enough because I don't remember. I remember there was AOL for one of those,
hmm
but not the other ones.
So basically, if I said that um, the bigger the dots are, the more internet traffic they had to deal with. Internet traffic means that people are connected to that website, or gaining some information or transferring some information by using those websites. So basically, it is the most popular website among all.
So I'm guessing then the search engines or
Yeah.
social media platforms.
Yeah, exactly. So here we have Facebook.com, Google.com, YouTube.com, Yahoo.com, and Live.com. Live for Microsoft, of course. What's that? Oh, WordPress. All right. There's also, I explored it a little yesterday, and the things I know is that we won't go here. This is like, you know, the not safe for work area of the internet. That's, not really connected to the main area of, United States based websites. The reason is that some websites are connected to other. For example, I go on Facebook, and on Facebook I see an advertising for the Google engine. So when I go to Facebook, most commonly the closer the dots are, the more direct the the path are between Facebook and the other website. So people, when they are on Facebook.com, mostly click on links that leads them to different website, which stand for all of these dots right there. Um, for example, designfix.com, activity.org, freezedpdsfiles.net, downloadspeed.com. All of these dots are, not connected with each other, but they like some sort of design for a path that
Would those
shows us.
sites be, for example, the advertisement that you would get on Facebook?
Yeah, exactly. And if I take, for example, Google, what's the Google? If Google was the first website I go to, for example, I type google.com, what would be the second website that I mu- I will go after that? So basically, the closer dots are from google.com, means that the more frequent people are going to go pass from google.com to that website using a link that is included into google.com. Okay, I'm not quite sure if this is clear enough. But anyway, you know, the main thing was to understand how websites are connected to each other. And if we take a closer look, I said that colored dots are mainly websites that are geographically located into a computer based in United States. And if we, zoom in to that cyan area where dots are a little smaller, I'm not going to zoom too much because I don't want to to see websites that are not, allowed. But so yeah, basically that you see that there connectivity between cyan dots and all the other colored dots, which also stand for websites that are located into other countries. For example, AU for Australia, the biggest website of Australia usually leads to Australian website. Yes, of course, but afterwards they leads to American websites. Okay, so every website are kind of connected between each other, and there's some area in that galaxy where you can see, for example, yellow. You don't see many of other colors inside that yellow area, as well as the red area here or the purple one over there. So um, I'll start with asking you, Alex. What do you think? Which country do you think owned those different colored area?
It's hard to say,
Okay.
judging by the blue ones that seem to be quite American, if we say at first
Yeah.
glance. Um, hmm,
There's not a lot of American website that is connected to yellow, as you can maybe
no.
observe. What does that mean? What do you think that does that mean?
I couldn't tell. I just know that, for example, if we take countries like China,
Yeah,
um, a lot of American websites are blocked
exactly.
or inaccessible. So my first
Exactly.
guess would be perhaps China.
Yeah, and that exactly what it is. This is actually CN.cn for China. This is the China networking of the most used website amongst the China network. And if we zoom in, you see, there's no, there's not much of variety of color inside, that networking, because China website usually refer to other China website. Okay, so, and that you mentioned it clearly. That's because some networks within different countries are, the access is restricted to the citizen of that country and that country only. If we take the red area, what do you think it would be? Or the purple one, maybe?
Those are really
Filling,
tiny.
yeah,
Um, they could be literally from anywhere, but I'm guessing just regions that are more um,
isolated.
conservative or
Yeah,
isolated, perhaps. Yeah.
yeah. So let's say Russia. So you guessed it right. Red one, the red. Well, actually, you didn't guess anything, but the red dots are actually stand for the website that are located in Russia, and the purple one are located in Japan. So yeah, and basically the other place, I'm not going down there, telling you, um, the other places are, a lot more connected with each other. That means the information is way more accessible. The American information is way more accessible for a person, let's say, that lives in Canada. There you go, google.ca, which is the most used, yeah, ranked number one in Canada, 62nd in global rank, 1.5% estimated percentage of global internet users who visit google.ca. And google.ca, it's actually linked with website from India, United States, of course, Russia, but this is not the case for example, China, which has a more more strict rules among the usage of internet and the information transfer. So I see time's flying by though. Yeah, this is interesting. I can be lost in that map for hours and hours. But we have to move on from now. So this was only to show you how the internet is and all of these information are so connected with each other that we just can't even imagine. And this is within like what 30 years maybe or so since 1993. So yeah, it evolved really rapidly, and I've talked about computers, I've talked about the internet, but without doubt, internet is considered by many as the most influential digital technology since 1990. Brown was saying this in 1999, but I think this never been so up to date now. So yeah. So need more examples. 94 first ever smartphone. 97 first ever modern social media website. 99 Bluetooth tech. 90 broadband system. Like Wi-Fi. First integrated in the UK. As we can make a comparison with the 5G technology. Firstly tested in the UK. 2003 was Skype, 4 Facebook, 5 YouTube. The social media era. 2007 first iPhone, first 3D printer in 2009. The Apple tablet computers. The first digital currency actually in 2011 with the bitcoins. First Google's driverless car in 2012 and 2016 virtual and amplified reality, to name few of them, because it evolves so fast since 1993. Look at all of the progress digital technology have made since the open source license of the World Wide Web. Yeah, there you go. So we've never seen so much new technologies in so few years since we invented fire back in 50,000 before Christ. So yeah, we rapidly in 20 years or so change over an industrial society to an informational society. But with the highly accessible information comes with a critical thinking or an ability to criticize the information that we might find on the internet. So yeah, and we didn't, like I said earlier, that technology evolves, faster than our capacity to do some research on that, on those digital technologies. So that means we didn't really equip our society with, let's say, cognitive framework in order to correctly used the digital technologies that today surround our daily lives. So and that's what they think about that. It's not new that we have this this thinking about teaching future citizen to really be able to understand that our technological and digital society. Yeah, this was in the head of in the mind of administrative people for years now. But still, oh, I just forgot to translate that slide, but I will do it en direct, live. So today, is there still today a part of or a sphere of our society for which the internet do have no influence on? Yeah, question mark. So yeah, is there any sort of sphere or dimension or a part of our society of our daily lives that are not connected, directly or not directly connected uh, to the internet, so it cannot have an influence on that dimension, that part of our society. What do you think, Alex? Is there
I think that, well, if we talk for educators, since this is an education course,
yeah.
um, no, I think that pretty much everything is going to be ruled and or made around some sort of internet, some sort
Yeah.
of technology. Of course, there are some people that still live off grid, if you
Uh-huh.
will, some people that don't access that. But even then, um, I think that people still try to stay connected in a way.
Yeah.
Um, like you said earlier, it is useful and it's reassuring as well to be connected
Mm-hmm.
with the world, in a way. So, I don't know. I am not sure what wouldn't be connected to the internet because even shopping today is something
Yeah.
that years ago we wouldn't have
Yeah.
thought would be connected to internet in the
Yeah.
slightest. Now you can do e-shopping,
Yeah.
internet shopping for
Exactly.
pretty much everything you need, and especially nowadays in the
Yep.
times that we've been living in.
Yeah.
So, yeah, I think
Yeah.
that basic needs um, are taken by the internet.
Yeah. And
And it's not necessarily a bad thing.
okay.
Um, it's a lot, but then again, the goal here is to make life easier, life go quicker.
Yeah.
So, yeah.
Yeah, and I've thought about finding a sphere or of our society that's not related to internet, that's not connected to the internet, and couldn't found anything. Internet is as important to us as oil, as have been for a century now. As important, well, and that made me think about the fact that internet may be considered as un besoin essentiel, essential need, maybe.
Yeah, essential need, and also just the fact that this course right now is available totally online just goes to show the importance of
Yeah.
internet and the technologies because education um, now you can get from anywhere in the world, basically.
Yeah, exactly. And this is the main reason also I said, and amongst other, other authors, I said that internet was probably the most influential invention that human ever created since 1950. Um, yeah, because it changes all everything that we interact with today. So yeah. So now, quick part about pedagogical use of digital technology. I know there's 3 minutes left. Theoretically, 3 minutes left. I'm trying to do my best to go as fast as possible. By asking a first question, of course. What was the first technology, digital technology, that you have consciousness of using at school? So yeah, I didn't know if we can call it digital technology, but that TV station that was wrapped on I don't know how to call it, but un genre de chariot.
It's probably.
Yeah, trolley. That every time I saw the teacher come in class with that thing, nothing can make me more happier than that. So yeah, early in 1970s, school was facing an audiovisual crisis. I'm trying to look for that word, but this is the best I could find. Equipment was actually fragile, bulky, costly, and often comes with compliance problems. With updates were not being made because they were not connected to the internet. For example, I use an software that's sold by Radio Shack. Yeah, why not? Radio Shack, and could not update it because I wasn't connected to the internet back then. So I had to go back to Radio Shack, buy a new software, a new version of that software, and it may cause the problem that you might think of. But aside these factors, what can explain this crisis? Well, for two main reasons, and this will make a interesting parallel with the situation of ICT integration in our schools today. First-time personal computers were. Oh, I thought I answered to that question. Well, first of all, money, which is obviously one of the main concern when it comes to any problems in the world. Well, not any, but most of them. Money and also training. Lack of training or lack of time to do some training. Teachers back in 1970 also had this problem of not having enough time to ensure their own training. We can also think about compliance problem, limited use also of those equipment. Uh, with the TV like this, I can play VHS and listen to movie or films. But except that, I cannot do much more with it. And look at the space it can occupy. So yeah, this is another problem that schools were facing at that time. First time personal computers were introduced in North America schools was in 1970, but schools, I mean instructional institution, more like universities and stuff like that. So I shouldn't say pupils, but students right here. So initiate the students to the computer technology. This was one of the two main goals of that introduction of the computers in class, and teach them the usage of commonly used software like programming software, other software for using by engineers, and stuff like that. So it was basically a a behaviorism uses of software, and less constructivism use of those software. So these are the two courant pensée, theoretical movement, let's say, that guided pedagogical brain. Sorry.
Train of thought.
Train of thoughts, yeah. Two trains of thoughts guided the pedagogical softwares or the use of those software offered with school computer. I do remember the first video game that I have to learn stuff was Adibu. I don't know if you can remember that as well, but basically this is training and drills. This is do exercises, answer a question. I give you live feedback, and this is it. You cannot create stuff with Adibu. You cannot express your own mind or trying to look out for solution to problems. I mean, there's a good and a wrong answer, and there's a good and a wrong way of doing things. This mainly concerned the behaviorism train of thoughts oriented softwares that were available with those computers at that moment. Mm. But still, there was some software that that were invented following some more constructivistic um, um, basis, let's say. For example, so yeah, behaviorism, usage of linear software, where pupils must repeat the same cognitive operation like drills and exercise in order to repeat what they saw previously. Constructivism, usage of non-linear software, where pupils are invited to explore multiple ways to solve one problem. One of the main and most reliable example was the use of the logo language, which is, well, regarding of my findings, the first programming language to ever be used in a pedagogical context with kids. Yeah, with children's. With kids. Yeah, so the logo language is a good example of a constructivist usage of computer software, because the pupils must enter, different code lines and different operators in order to create a visual effect or a visual representation of that operation. So yeah. So for example, repeat 20, repeat 180, forward 1, right 2, right 1. So this way it can create this sort of Expo 67 big thing. I don't know if it's a real thing, but yeah, this is a constructivistic way of thinking of a software that can be used with computers back in the mid 70s. Yeah. Which is, well, interesting fact that logo language was developed by Papper, who studied basis of constructivism with Piaget at Genève's University back in the day. So Piaget may be a little bit influential into Papper's works back in the days. I didn't ask him, but this seemed pretty obvious to me. So yeah, this actually makes students the focus in the learning process instead of being the computers, being in the center of the process. So it helps to develop a procedural way of thinking. And later on, we saw coming of more the physical structure that can be constructed beside the usage of the logo language for programming, and so we can build Lego structures to then connect it to a computer that is using the logo language software in order to program the movement of that Lego structure. So this one of the first robotic experience that was experienced in school was with the Lego logo that we during the 80s. I know I'm going fast for these few slides, but we're almost done. If you have a question, don't worry. I'll be available by email, so you can still email me anytime you want. So unfortunately, well, probably speaking to my students, of course. Unfortunately, technology implementation in school is still unsuccessful and laborious process, especially because of, well, school's rigid structure, and that you don't put computers in every school. Not every school are designed to to have a computer local or something like that. So yeah, the school structure was one of the main reason for that implementation failure, and also refractory. And I don't like using that term because it puts most of the responsibility on teachers' shoulder, which I think is really unfair to do so. For many reasons, school actors were not allowed to, were not, um, in a position to integrate those technology into their classroom. Yeah, and by school actors, I included as well teachers, as administrative people, ministry, direction, yeah, and so on. So everyone is in the same boat. No one uh, is having a bigger part of responsibility. So yeah, the stowage between digital technologies and pedagogy is therefore timid, episodic, and comes with a limited pedagogical potential, as we just talked a few seconds ago. And I think I finished with a few quotations that I found really, relevant to the topic. So, educational system seems to be disconnected, or at least not synchronized, from the social function technology as at that time. I really had hard time to translate that that last sentence, but that refers to what Alex was saying at the start, the beginning of that live streaming, which was correct me if I'm wrong, but you said that it's the social responsibility to school to adapt their structure to kids' reality in order to keep them hanging uh, to the school.
You want to keep your students engaged in their
Yeah,
learning, so adapting yourself to their reality, in this case, technology,
yeah,
or certain uses of technology is the way forward,
mm,
and also an easier way to place them at the center of their learning,
yeah,
and not have a teacher speaking in the front
yeah.
who is using younger learners,
Uh huh.
because university we can do that. We're mature enough, well, most of us, to
Yeah,
just listen to a person and take notes.
yeah.
But the younger learners, they need to be more involved in their learning. So,
Yeah, and implementation of that digital technology that's been using that's been used, sorry, by kids doesn't mean simply using the smart board for projecting, video on YouTube or stuff like that. It's more the integration, like it's part of the learning process. That I mean, students have to manipulate those digital technologies, have to work with them in order to understand what they do, and in order also to understand how they are made of, okay, and how they work, just as we introduced today in that class. um, are we still today in a position to observe the same kind of spacing between the users, sorry, of technology in school and its social function, role, importance, or whatever among kids? Well, I'll let you answer that question in your head, but I think that yes, of course, there's and there will also always be a spacing between the use that we do, the use that we make of technology inside of our classroom, and the use of technology that kids the kids usage of technology at home. Of course, there always will be a spacing between those two realities, but you know the role of the function of school is actually reduce that distance between the kids' reality and school reality, because even within the kids themselves, I mean, there's distance between a kid living in Montreal and a kid living in back backyard country. Well, how to say that? Un rural,
Rural countries, so on
rural.
the countryside.
Yeah. So
Saint-Roch-de-l'Echigan, if you will.
yeah, yeah. So there's technological distance. There's digital distance between the understandability of those technological tools between kids that living in Montreal, for example, and another kid that's living in Saint-Roch-de-l'Echigan, as an example. So school as the social function to reduce that technological spacing between kids, and also between school itself as an institution and the reality of children's. And this is achieved by integrating not only from a technical part the technology, the digital technologies, but talking about them, being more conscious about the uses that we made of our smartphones and our tablets and our computers and stuff like that. Understand how they work, what's the effect of them on us and on our society, as well as our mental health, physical health, on our democracy, as we will see during the semester. How technology have changed, things that we might think that was unchangeable or not possible to be changed, like democracy, but the way of expressing our citizenship role in our society has changed with the introduction of digital technology. So yeah, and this I think the last one. Yeah, according to Rosnay, and I also shared his thoughts on that. The implementation of technologies inside classroom have the effect of reducing the digital spacing between those who are used to technology and those who are not. Even if nothing can guarantee that digital technologies, will automatically have benefits on learning. So it's not because I introduce technology that it will have a positive effect on learning, but it will have a positive effect on reducing that gap or that spacing between between kids themselves, so they could keep progressing with less inequality in terms of technology, because technology actually is part of most of our interaction. So yeah, understanding technology, and it's a good way to start with children. So moving beyond traditional pedagogical methods, so I kept the French version of that quotes because I think it's more relevant to us, but I'll keep trying to translate it. So school cannot ignore what's happening in the world. New technologies are transforming ways of communicate, but also our way of working, of thinking, of decide, of doing democracy, and that's true. And school cannot live under a rock for too many years. It has to one day to another. Otherwise, someone else will take care of that digital and technological education, and that won't be well. And this way, there's no way we can guide those learnings, and yeah, about the technology. So yeah, that was it for today's class. I know with in the class syllabus there was indicated that we do more than that, like exploring the digital competency framework document, and also looking for trying to understand how to properly use research tools. But that will be for next class, because actually I'm 18 minutes over the limit time of this class. So I'm sorry about that. I'll try to finish class 18 minutes earlier next time, which is sorry, I have it right there, which is on May 11. So next Monday at 9 a.m. Same spot, same time. I will yeah keep going with the end of that first class, and then we will talk about the reliability of sources on net, and writing skill and writing processing softwares that we use in school, and how they can affect our way of learning and teaching things. So, is there any questions about today's class? I don't know if Alex, you have a question uh, regarding information that I may have given today.
Mm. Not so much a question about the information, but if you had to summarize today's course, what
Yeah.
should people remember?
0 and 1. Basically that technology is, everywhere. Okay, we cannot, hide ourselves under a rock and, act like it doesn't exist. So digital technology is now part of our society, and now we have to deal with it. Okay, and in order to deal with it, it's, well, in part, the school's social responsibility to teach students the good way of using technology, the good way of of using those technology, and also maybe put a little more efforts on understanding what we're actually doing. Not telling you to have a 45-hour class on programming, but understand that 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 digital j'ai oublié le nom, digital process thing is everywhere, that internet is connected through different digital tools that we have never thought it would connected, like a dryer, for example. And if we want to keep evolving, in a society where we still do understand what's going on, we do have, okay, it's not even an option. We do have to keep informing ourselves on, what are the effect of those technology, how do they work, and stuff like that, in order to keep our head out of the water, and still have a clear understanding of the new development of those technology in the future. So and that digital learning is not only based on technical learning of like how to adjust margin on a Word document, for example. This is part of the technical learning process, but also critically think about the impact of those technology among our lives, our society, and the foundings of those society, aka our democracy system. So yes, this was an introduction to digital technology as we may experience today. So where it comes from, why that digital technology emerged. It seems like it was just there when we were born, but that's not the case. And yeah, so that way it will be, I think, even more clear to see where actually the technology is going with, and there's so much more to discuss about. But I think this was, a good introduction to that topic. I think that summarizes up, pretty much that class today. What do you think?
Yeah, I think that's pretty good.
Cool. And anything to say before uh, turning off, stop the streaming?
Well, for me, I mean, this was an interesting class,
Yeah.
and like I wrote to you, I won't be present for the next class,
Okay.
but um, I think it's not as interactive as I thought. So, I mean, at least if you have trouble understanding students, it will be by probably written form, so
Yeah.
you have time to look for it. So, no, I enjoyed my
All right.
experience. I hope that
Cool.
people liked it too,
Yeah.
and very interesting.
All right. Cool. Cool. At least if you enjoyed your time, so you don't feel like you're working at the moment, um, and that's good news for everyone. So, yeah. Well, thank you, and I'll catch you up next Monday, 9 a.m. For the part two of that introduction to digital technology. Uh, Still remember the you know I'm still available for question. You can send me emails or simply comment on that comment section below the video, sorry. So I will try to answer your question back, and yes, see you next time. Thank you, Alex, by the way. Oh, I forgot to mention it. Thank you, Alex, for your time. It's really appreciate the time you've been spending for helping me out with English, and also feeding that discussion is always a good way to yeah to talk
It's a
about
pleasure.
yeah. Cool. Hey, thank you, and see you next time.